In this video, we're going to learn how to take an area under the normal curve or a probability and find the associated value in the normal distribution. This is also sometimes called finding a percentile, and we're going to learn how to do this in GeoGebra. For example, let's say you're in a normal distribution with a mean of 22.8 and a standard deviation of 5.4. What value will have 10% more than it? Well, if you have 10% more than, then there's 90% less than. In other words, this is the 90th percentile. So how do we do this in GeoGebra? Well, we're going to have 10% more, so we need the more than. Then we put in the specifications for the parameters. So 22.8 for mu, 5.4 for sigma. And then we want this to be 10%. So we go to the proportion form, the 0.10. Then when we go to GeoGebra, the percentile will pop out in this box here. So we go over to GeoGebra, we have to turn on the probability calculator. So we go to probability calculator. We're in the normal distribution. The mean 22.8, standard deviation 5.4. So we want more than, and we want the amount more than to be 0.1. So the graph matches what we're thinking about in that problem, and sure enough, that percentile pops out right here in here. So the value in this distribution, such that 10% is more than it, is 29.7204. Last example here, Eric's height is at the 40th percentile. In the text, we showed Eric's height to be 5'9". So let's do this calculation in GeoGebra. And it says, recall that the mean for male heights is 70 inches with a standard deviation of 3.3. Well, if he's at the 40th percentile, then he's got 40% of the population below him. So we're going to use the first bracket here, and we want that area to be 40%, so we write as 0.4, and then his height in inches will appear in this box here. So we go over to GeoGebra, we put in 70 and 3.3. We put in 0.4, and we look at the picture. Oh, forgot to change this. So 40% of the population is below. Oh, that's why we need a 0.4. So this picture agrees with what we're thinking about. If he's at the 40th percentile, he's a little bit under average, but not that short, right? So yeah, that looks like about 40% right there. And sure enough, we see Eric's height popping in right here at 69.16. So 69.164 inches. So we need to show that that's 5'9". So 69, if we divide 69.164 by 12, that's going to be 5.76. So the 5 feet, and then we have 0.76 feet. So we're going to multiply that by 12 inches to get a number of inches, and that will be 9 inches. So we see the 5 foot, 9 inches, which is what we showed it to be in section 3.2.4.